Hey, what is up everyone? Welcome back to another video. In this video, we're going to go through the new TryHackMe room all about advanced SQL injection. We're going to cover a bunch of things. We're going to get hands-on practice with second-order SQL injection, filter evasion, out-of-band SQL injection, automation techniques, and mitigation measures. So without any further ado, let's go ahead and dive into this room. If you want to follow along, it is the advanced SQL injection room. I always forget to check if anyone, it's a free room as well. So for those of you watching in chat, get TryHackMe pulled up. This is one of the most recent rooms, so you should see it on the sidebar. Otherwise, advanced SQL injection, it is completely free, so you guys can jump in and join me. Proze said over on Twitch, anyone care to share a link to Discord? Look, I will share a link to you for Discord while I'm streaming. Go to hacksmarter.org. And on hacksmarter.org, this is our website. Just click here to join us on Discord. You'll get a Discord link, as well as check out some of the community resources from people in the Hack Smarter community. But let's jump back over to TryHackMe, and let's go ahead and dive into this room. I did already boot up my machine, so I'll zoom in so you guys can see it a little bit better, and let's try to understand everyone's favorite, just kidding, SQL injection. I'll be real with you guys, I suck at SQL injection. Like, if SQL Map can't do it, generally speaking, neither can Tyler. So I'm very looking forward to diving into this room myself and seeing what I can learn. So SQL injection remains one of web applications' most severe and widespread security vulnerabilities. This threat arises when an attacker exploits a web application's ability to execute arbitrary SQL queries. First, let me ask you guys in chat, SQL or SQL? You guys can argue in the comments. I like saying SQL. SQL is just, it's too long. SQL flows better for me. So I'm going to say SQL. If that drives you crazy, well, that sucks. Do it on yourself. Leading to unauthorized access to the database, data exfiltration, data manipulation, or even complete control over the application. In this room, we will understand advanced SQL injection techniques, providing a comprehensive understanding of sophisticated attack vectors and mitigation strategies. By the end of this room, we will have a deeper understanding of the various SQL injection techniques. This will equip you with the skills to identify and exploit these vulnerabilities in multiple scenarios and implement robust defenses to protect your applications. Here are the key things that we are going to learn about. Some learning prereqs. We'll just see if we can dive in and do it. And now connecting to the machine. I've already done this. Here is our machine, and it says, hey, the first thing you might want to do is scan it to see what type of database might be running. Now, generally speaking, if you're doing like an external pen test, the database isn't going to be exposed to the internet. At least it shouldn't be if it's configured properly. But on an internal pen test, you will often see databases there because, well, they need to work with them. So I'll go ahead and run this command, but let me just show you what it's doing for those of you who might be new. It's using Nmap, a standard tool for network scanning. Actually, I'll run the scan first and then I'll explain it. But I'm guessing it shows us the full output down there, so we probably don't even need to do this ourselves. But we're running Nmap, and then we're doing the -A flag. If you ever watch me do CTFs, you'll notice I use this flag all the time. This just means they're all the enumeration scripts at the ports that we want to find. Find version information, service information, everything that you can. T4 is the speed, the threading. So we're saying do it a little bit faster. I think Nmap goes up to T5, so it's not quite the fastest, but T4, do this quickly. And then specifying the ports that we want to scan. So we want to scan port 3306, which is common MS SQL, 3389 RDP. We have some SMB ports in here as well. So we know just by looking at this, this is a Windows machine, but scan these ports on this target IP. And if we jump over to this, you can see it's already done. So we can see we have the SMB type stuff going on here. We have MySQL going on right here, and we have RDP running on 3389. So we know we're working with MySQL and MariaDB, which is helpful because our syntax for SQL injection is different depending on the SQL database that we are attacking. So what is the port on which MySQL is running? Well, that's 3306. All right, look at that. My streak has increased. Beautiful. Quick recap. In the last SQL injection room, we explored the basics of SQL injection. Did I do that room? Oh, there's not a link here. It'd be nice if there's a link to that room here. We explored the basics of SQL injection, understand how attackers exploit vulns in web apps to manipulate SQL queries and access unauthorized data. We covered essential techniques such as error-based and union-based SQL injection and blind SQL injection methods such as Boolean-based and time-based attacks. Here's a quick recap of the room covering the core essential types of SQL injection. So what do we have here? Let me zoom out a little bit. So types of SQL injection, we have in-band, which means we can see the output right away, error-based, union-based. We have out-of-band, which means, hey, it might communicate via HTTP, DNS, SMB, just another channel to get the information. And we have inferential. So we can tell based on the application's response whether or not it's vulnerable. Boolean-based, which is true or false, and then time-based. So we can say, hey, sleep for 10 seconds if this is vulnerable. In-band SQL injection. This technique is considered the most common and straightforward type. This is stuff I probably already explained. Yeah, same communication channel. Error-based SQL injection, this attacker manipulates a SQL query to produce error messages from the database. These error messages often contain information about the database structure, which can be used to exploit the database further. For example, select everything from users where ID equals 1 and 1 convert integer version, so it's going to error out. If the database version is returned the error message, it reveals information about the database. We have union-based SQL injection. The attacker uses the union SQL operator to combine the results of 2 or more select statements into a single result, thereby retrieving data from other tables. Example, select name and email from users where ID equals 1, union all select username password from admin. All right. Inferential or blind SQL injection. Inferential SQL injection does not transfer data directly through the web app, making exploiting it more challenging. Instead, the attacker sends payloads and observes the application's behavior and response times to infer information about the database. There are 2 primary types of inferential SQL injection. We have Boolean-based. The attacker sends a SQL query to the database, forcing the application to return a different result based on a true or false condition, right? So select from users where ID equals 1 and 1 equals 1, which is true, versus select from users where ID equals 1 and 1 equals 2, false. So true or false. The attacker can then refer the result if the page content or behavior changes based on the condition. And of course, time-based. Very similar, except for we make it sleep. We know if it sleeps for 5 seconds and we can read that, then our query is true. All right, out-of-band. Out-of-band SQL injection is used when the attacker cannot use the same channel to launch the attack and gather results, or when the server responses are unstable. This technique relies on the database server making an out-of-band request, HTTP or DNS, to send the query result to the attacker. HTTP is normally used in out-of-band SQL injection to send the query result to the attacker server. We will discuss it in detail in this room. Looking forward to it. Each type of SQL injection technique has its advantages and its challenges. Understanding these techniques is crucial for identifying and mitigating SQL injection vulnerabilities in web apps. In-band SQL injection is easy to exploit and detect, but noisy and can be easily monitored. Inferential or blind is more challenging to exploit and requires multiple requests, but can be used when detailed error messages are unavailable. And finally, out-of-band SQL injection is less common, but highly effective, requires external server control, and relies on the database's ability to make out-of-band requests. By mastering these techniques, pen testers can effectively identify and exploit SQL injection vulnerabilities, helping organizations secure the web apps against these critical threats. Boom. There we go. First page is done. All right. What type of SQL injection uses the same communication channel for both the injection and the data retrieval? Well, that one is going to be our in-band SQL injection. I'm quite sure. And in out-of-band SQL injection, which protocol is usually used to send query results to the attacker server? All right, here we go. I think we're going to get hands-on. We are. So for the hands-on stuff, what I do want to do is open up Cato. Cato is a web proxy tool, sort of like Burp Suite, but written from the ground up in Rust. And the reason I show Cato on CTFs and live streams is when you use Burp Suite Community Edition, you're rate limited on intruder attacks. With Cato, even with the free version, you're not rate limited on those intruder attacks, and it'll all just work. So just better for CTFs, from my humble opinion. We'll create a project called Advanced SQL Injection, and we'll go over to Intercept, and I'll just open up the browser built into this. We'll use Google Chrome. That way I don't always forget to turn off my proxy. All right, let's dive in. Second order SQL injection, also known as stored SQL injection, exploits vulnerabilities where user supplied input is saved and subsequently used in a different part of the application, possibly after some initial processing. This type of attack is more insidious because the malicious SQL code does not need to immediately result in a SQL syntax error or other obvious issues, making it harder to detect with standard input validation techniques. The injection occurs upon the second use of the data when it is retrieved and used in a SQL command, hence the name second order. And I think there was a TryHackMe room I did somewhat recently where this was the exploit or the way in. I just don't remember the details, but I remember digging into this a little bit. So we can see it here. right? Select from books where book title equals intro to PHP and is stored on here. And then when it executes here, it executes the query. The danger of second-order SQL injection lies in its ability to bypass typical front-end defenses like basic input validation or sanitization, which only occur at the point of initial data entry. Since the payload does not cause disruption during the first step, it can be overlooked until it is too late, making the attack particularly stealthy. Example, we will be using a book review application. The application allows users to add new books via a web page, add.php. Users are prompted to provide details about the book they wish to add to the database. You can access the app here. The data collect includes the SSN, the book name, and the author. All right, let me just pull this up and have a look at it myself real quick. All right, we'll say send how to be a That's my feature book. All right, there we added a book. Let's go through. As we know, second-order SQL injection is notably challenging to identify. Unlike traditional SQL injection, which exploits real-time processing vulns, it occurs when data previously stored in databases is later used in a SQL query. So we need to find a way to reuse, maybe update information or something. Detecting this vulnerability often requires understanding how data flows to the application is reused, necessitating a deep knowledge of the backend operations. Looking over at chat, Kevin said, will you showcase manual exploitation or via SQL map? I think both, my friend. I think we're going to do both in this room. The faceless point of view said, hey, Tyler, do you get writer's block? If you do, how do you overcome it and keep hacking consistently as a habit? Yeah, I mean, sometimes I struggle from lack of motivation, for sure. A big part of it is just doing it when you don't feel like it, but also recognizing your limit. So there's times, guys, when like I tell myself, you know, I'm going to stream tonight, I'm going to showcase a room, but then once I get my kids finally to bed, or once I exercise, I'm like, dude, I don't feel like turning on all my camera stuff. I just want to like go to Tamriel and play Elder Scrolls Online, right? And I just do that. You have to be able to read your body. But when it becomes like a regular thing, when you're not studying or learning at all, sometimes you just have to dive into it and also be part of a community. So at Hack Smarter, we have a Discord community, and we host weekly goal meetings every single Monday for anyone and everyone to attend. And at those meetings, we encourage people to answer 2 questions. What did you accomplish this past week? What are your learning goals for this upcoming week? And knowing that you're going to have to answer those questions honestly, at least for me, helps me be motivated. So those are some suggestions. All right, let's do code analysis. Consider the PHP code snippet used in our application for adding books. So we're doing a post request here, and you can see we're trying to do real escape string, which I think can be pretty easily bypassed, I believe. But that's all it's doing on the data that the user is giving it. It's not using parameterized queries, which is the way you should be stopping SQL injection. It looks like we're doing it for all of this. So we're doing our SSN, our book name, and our author. And then our SQL statement, you can say it's seeing insert books, blah, blah, into those fields, and the values. It's taking the values directly from what the user is supplying to it. So it's using user-supplied input directly in a SQL query, which is, of course, going to lead to a classic SQL injection. And then it's going to say, hey, if true, new book added successfully. So the code uses the real escape string method to escape special characters. While this method can mitigate some risk of immediate SQL injection by escaping single quotes and other SQL meta characters, it does not secure the application against second-order SQL injection. The key issue here is the lack of parameterized queries, which is what I said, which is essential for preventing SQL injection attacks. When data is inserted using the real escape string method, it might include payload characters that don't cause immediate harm, but can be activated upon subsequent retrieval and use in another SQL query. For instance, inserting a book with the name like Intro to PHP drop table books might not affect the insert operation, but could have serious implications if the book name is later used in another SQL context without proper handling. Let's try another book with the SSN test. Here we go. The SSN test is successfully inserted in the database. The application includes a feature to update book details. Okay, that's what I was looking for the second order, to update book details. This interface might display existing book details in editable form fields. Let me just go to that. Do we go to update.php? And classic thing that we might have SQL injection going on. You do single quote, and if you get, it's often a 500 error or a SQL error like this, very obvious. When you see an error saying that you have an error in your SQL syntax, hey, we might be dealing with some SQL injection. Whoops, didn't mean to do that. I can't, oh, can I update the SSN here? No matter what, that does that. Okay, let me jump back over to update, or add.php rather. Blah, blah, this interface. Okay, the pen server to investigate whether the application uses the data, which we just noticed. Then he or she would construct SQL queries for updating records. Okay, by manipulating the update feature, the tester can see if the malicious payload added during the insertion phase gets executed, which we saw that it does. If the application fails to employ proper security practices at this stage, the earlier injected payload drop table books could be activated, leading to the execution of a harmful SQL command like drop it like it's hot. Drop in that table. You can visit the page there to update any of the book details. Now let's review the update.php code. All right, let's check it out. So we're doing a post request to update. We have our unique ID, SSN, book name. So very similar once again. You can see it's taking our user input and directly adding it to the query. Update book set book name equals new book name, author equals new author, where the SSN equals that, insert into logs. And if we modify the SSN when we add the book, this is where it's reusing the SSN and it's doing that second order SQL injection. So the script begins by checking if the request method is post and if the update button was pressed, indicating the user intends to update the book's details. Following this, the script fetches user details, etc. These variables are then used to construct a SQL query for updating the specific book's details in the database. The script uses multi-query to execute multiple queries. It also inserts logs in the logs table for analytical purposes. All right, preparing the payload. We know that we can add or modify the book details based on their SSN. The normal query for updating a book might look like this. Update book set book name equals new book name, author, new author, where the SSN equals that. So we want to escape right there. However, the SQL command could be manipulated if an attacker inserts a specially corrupted SSN value. For example, the attacker uses the SSN value this, it will update all the book names. All right, because look, it's seeing this SSN right here. That's the value right there, and then we are just continuing it. So then it's adding this onto the end of that to do the multi-query stuff. So we can go ahead and try this. If I jump over to this, right, we don't see anything right there right away because the fact that it's second order SQL injection. But now if I go to update.php, and if we say lols with another Z and update, look at that. Every book name has been changed to hack. I'm just going to make this easy. Let me just open two tabs here. All right, let's do this. Initial pay. Okay, I already did this. Updates the book, blah, blah. And then we comment out the rest, which is what the dash is. Anything following that will be ignored. So you think about comments in HTML, similar as well. All right, cool. In this task, we explored second-order SQL injection concept through a vulnerable book review web app. As a pen tester, examining how user inputs are stored and later utilized within SQL queries is crucial. This involves verifying that all forms of data handling are secure against such vulnerabilities, emphasizing the importance of thorough testing and knowledge of security practices to safeguard against injection threats. So what is the flag value after updating the title of all books to compromised? Well, that shouldn't be too hard. We can literally copy this payload and we can change this maybe to compromised. Lols again, lols. All right, just refresh this page. And there's my flag. What is the flag value once you drop the table hello from the database? It'll be something very similar to this if we consider the query. So intro to elite hacking, right? So there's our book, our SSN. And remember, we're escaping, we're closing out our SQL right there, and then we're doing another query right here. And this one, we're dropping a table. I don't remember what table it wanted me to drop, though. Dropping the table hello from the database. So we're going to drop the table hello. All right, add book. Add another L to lol. And I broke it. Undefined index. Let me think. Can I just fix these real quick, or will this all break now? All right, let me jump back to my book thing. Maybe my eliteness is what broke it. What if I just use their standard payload right here? I think that would work, but instead we'll drop the table hello. What? Undefined index. Guys, I can't even complete the first lab because I'm freaking dumb. Did I break something with my other SQL injections? Can I delete my SQL injections at all? Pretty sure I'm doing it the right way, where I'm just dropping the table. But I don't know. I don't know how to delete these. Know what I mean? I can't fix them. I'm not doing anything wrong. I'm quite certain about it, that I'm not doing anything wrong. No, you don't have to first create the table. I'm pretty sure I just broke it with all my other SQL stuff. No matter what I do, it's going to hit those errors because it's like trying to update the other ones and it's bugging out with the other ones. There, look at that. I got it. See, I literally didn't do anything different. What if I do this one now? Yeah, it works now. It just gives me the same errors, but it seems to work. Whatever. I got it working. All right. Filter evasion techniques. Let's dive into this. Let me check out chat, too. Make sure I'm not missing anything. BD said, Ty, did you pay out of pocket for the OSCP? Yes, I did. I didn't have an employer that would pay for it. King Tech said, when on a pen test engagement, do you ask the client to put their antivirus EDR to alert only and not prevent? I can't seem to get around EDR sometimes. Yeah. Yeah, like once again, difference between pen test and a red team engagement. A red team engagement, you have to be stealthy, right? The client doesn't know you're in their environment. Pen test, time-limited engagement, usually 5 days. They don't want you wasting your time trying to bypass EDR. They just want you to find all the vulns that are possible. So generally speaking, they will not use their EDR to stop your attacks. All depends on the client, of course, but generally speaking, that's how it is. BD said, was it worth it? I don't know, dude. It all depends on each person. I signed up for the OSCP before I had a pen test job, but I landed my pen test job I have now before I took the OSCP. So I got this job, and then it was like 2 weeks later my OSCP was scheduled and I passed it. So it hasn't helped me get my job or anything, but generally speaking, OSCP does help people land pen testing roles. All right, filter evasion techniques. In advanced SQL injection attacks, evading filters is crucial for successfully exploiting vulnerabilities. Modern web apps often implement defensive measures to sanitize or block common attack patterns, making simple SQL injection attempts ineffective. As pen testers, we must adapt using more sophisticated techniques to bypass these filters. This section will cover such methods, including character encoding, no-quote SQL injection, and handling scenarios where spaces cannot be used. We can effectively penetrate web apps with stringent input validation and security controls by understanding and applying these techniques. All right, character encoding. Character encoding involves converting special characters in the SQL injection payload into encoded forms that may bypass input filters. So we have URL encoding, right? Instead of that, you just URL encode it. You can do that with CyberChef, Burp, Cato, all of that. Hexadecimal encoding, very similar, but you're doing hexadecimal. It looks like on the admin name right there. And then Unicode encoding, that's how you encode admin in Unicode. In this example, we will explore how developers can implement basic filtering to prevent SQL injection attacks by removing specific keywords and characters from user input. However, we will also see how attackers can bypass these defenses using character encoding techniques like URL encoding. So we need to go to this page right here. All right. And let's see what this developer is trying to do to us now. We are doing a GET request on book name, and it says, hey, we're defining a variable called special characters in an array. So or, and, union, or select. If book name, so we're specifying a new variable called book name, string replace. So any special characters in the book name, replace it with a just nothing, blank, a blank spot. And then our SQL query, select everything from books where book name equals book name, and then generate a SQL query. So is this trying to like say, hey, if any of these are in there, it's going to fail, and we can even check that. Like if I say and, right? Oh, maybe that won't fail. Is it or? Oh yeah, you can see it's not even coming with the book. So if we do intro to PHP, I think was one of the books. We can see the book name there, intro to PHP. If we do and on the end, it won't include it. It just adds that space, and that's what that filtering is doing. Then the user interface for searching for books. There's our key right there, and then our encoded URI component. In the above example, the developer has implemented a basic defense mechanism to prevent SQL injection attacks by removing specific SQL queries, or keywords rather. The filtering uses a string replace function which strips these keywords from user input before they're included. But I bet it might even talk about this. Intro to PHP. So you could bypass it like that, and that would still be executed by SQL. Anyways. Preparing the payload. Let's go through the process of preparing a SQL injection payload step by step, showing how the URL encode can bypass defenses. So intro to PHP, if we try to add a query, we get that. So that shows that, hey, SQL injection might be possible. Right? And then they're trying to inject the payload intro to PHP or 1 equals 1, right? Which will always be true. It's going to fail because of the or, right? It takes the or out. But what if you did this? Lowercase o. Oh, it sees it there, but it still fails. Interesting. I thought maybe that would work. So what is happening here? When this input is passed to the PHP script, the string replace function will strip out the or keyword in the single quote, resulting in sanitized input. To bypass the filter, we need to encode the input using URL encoding, which represents special characters and keywords in a way that the filter does not recognize and remove. Here is the example payload, right? URL encoded for a single quote. the URL encoding for a space, or in SQL. The 3D is the URL encoding for the equal sign. I don't see that. The equal sign's actually there. Same with that. It says that's the URL encoded for the dash dash, but the dash dash is actually there. Okay. Is what it is. In the above payload, the 1 closes the current string or value in the SQL query. For example, the query is looking for a book name that matches 1. Adding that closes the string, making the rest of the input part of the SQL statement. Or 1 equals 1 part uses the SQL or operator to add a condition that is always true. This condition ensures that the query returns true for all records, bypassing the original condition that was supposed to restrict the results. Similarly, the dash dash inserts a comment in SQL, causing the database to ignore the rest of the query. This is useful to terminate any remaining part of the query that might cause syntax errors or unwanted conditions. To ensure proper spacing, a plus add a space after the comment, ensuring that the comment is properly terminated. There are no syntax issues. From the console, we can see clicking the search button makes an AJAX call to search books. Right, so we probably just want to do it directly from the URL. Yeah, okay, that's what I was thinking. Let's use a payload directly in the PHP page to avoid unnecessary tweaking or validation from the client. Let's visit that, and we will get an error. Oh, and then we're going to URL encode that using CyberChef. Okay, let me try this. Boom. Send a replay. We'll send it. Right. We can render it real quick. And we have an error in our SQL injection. So instead, what we want to do, can I do it right here? What if it's already URL encoded. No, okay. So we do have to take this payload right here. Right? Can I do it like this? Wait, we need... Yeah, here's the payload we need right here. And then we're going to URL encode this payload rather. So I'll go like that. And here in Cato, whoops, if I could actually highlight this properly, we can do convert URL encode. Just turn off rendering. Okay, select everything from books where book names equals intro to PHP or 1 equals 1. Was I supposed to actually get something? It actually processed my query, but it didn't work. Does CyberChef encode it a little bit differently? They're not using the same payload here. They're using the 1 payload. Okay. And let me try it a few different ways. I want to understand exactly what is going on. So here's a payload it's telling me to use, and we want to URL encode. Like that, like so. Jump over to here. Paste that in. There wasn't much that changed. Oh, I guess it changed a little bit. And then it does it properly. So why didn't mine work? So mine, Cato, was not URL encoding the OR operator there. You see that? But it looks like the same... same query. Okay. My curiosity is getting the best of me. I want to quite understand why. Is it really just that right there? The or thing that's not being URL encoded properly? Let me try it again. It was the plus. That's all it was. It's just the plus on the end there. It was URL encoding the plus, but we didn't want the plus URL encoded because we wanted that space there. So by fixing that, then you could also just do it directly in Cato by URL encoding that. Got it. See, curiosity gets the best of me. You have to know why something doesn't work. Malware Combat said, what is Cato for? It's like Burp Suite. That's what Cato, it's a proxy tool. Just like Burp Suite. Okay, I got that. The payload works because URL encoding represents a special character and SQL keywords in a way that bypasses the filtering mechanism. When the server decodes the URL encoded input, it restores the special characters and keywords. What if I do it this way? Yeah, I'll just send another one over here to repeater. What if I do... Oops. That also does it. You guys catch that? So the reason that one works, you don't even have to URL encode it, because if you look at their code, the developer's code that they're trying to prevent our SQL injection with, notice that they're just looking for these special characters. So I can still use or by doing like a capital O and a lowercase r, and I get the same results that way without even having a URL encode it. So interesting little unintended way of doing that without URL encoding it. Okay, what is the MySQL error code once an invalid query is entered with bad characters? Okay, so to get that information, we can just go back to this. And the error code is 1064. We can see that information right there. All right, drink of water. Zach said, Cato looks way nicer than Burp in my opinion. Yeah, and it's way cheaper too. I mean, you can get free Cato. I have a pro edition of Cato, but it's only like, I don't know. When I signed up for Cato, it was only $10 a month. They've raised prices a little bit since then, but I got like grandfathered into my rate. But it's still maybe $15 a month, way more affordable than the whatever. I don't even know what Burp Pro costs right now, right? What does Burp Pro cost? $450? All right, Cato, you can get Cato Pro for $200, right? So it's very affordable. Anyways, what are we doing? What is the name of the book where book ID equals 6? So I'm thinking what we can do is something like aha, there it is. So you can see my SQL query. I just did intro to PHP or book ID equals 6, and it gives us the book ID of animal series. All right. So far, so good. Yassine said, can I ask why we need a space at the end of the injection? I think is just so it encodes properly. They actually talk about it up here. To ensure proper spacing, a plus adds a space after the comment, ensuring that the comment is properly terminated and there are no syntax issues. Because if we take away that space, I think it'll fail. Yeah, you can see it fails. It wants that space there after our comment. And by adding the space, it succeeds. Now, I suppose the intended way of doing this, guys, was to just URL encode all of it, which you can do that as well. But either way, you're doing filter evasions. We looked at the code. We saw that they're doing it by OR. So if I would have done a capital OR right here, it will fail. Watch. Right? It's going to fail because it's not reading the OR. It's stripping it out. But they're only looking for like OR capital or lowercase. But if you split it like that, it still succeeds. All right. I usually end SQL with dash 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 so that space doesn't get automatically removed. What do you mean, like this? Or like that, you mean? Oh, like that. That's what you mean. Gotcha. That makes sense as well. All right, more filter evasion techniques. No quote SQL injection. No quote SQL injection techniques are used when the application filters single or double quotes or escapes using numerical values. One approach is to use numerical values or other data types that do not require quotes. For example, instead of injecting a quote or 1 equals 1, an attacker can use or 1 equals 1 in a context where quotes are not necessary. This technique can bypass filters that specifically look for an escape or strip out quotes, allowing the injection to proceed. Using SQL comments. Another method involves using SQL comments to terminate the rest of the query. For instance, the input admin and then quote dash dash can be transformed into admin dash dash. Those are the comments, where the dash dash signifies the start of a comment in SQL, effectively ignoring the remainder of the SQL statement. This can help bypass filters and prevent syntax errors. And using concat functions. Attackers can use SQL functions like concat to construct strings without quotes. For example, concat that constructs a string admin. The concat function and similar methods allow attackers to build strings without directly using quotes, making it harder for filters to detect and block the payload. I would assume that filters might detect concat, though, in most of the time. Frank said, imagine someone would tell PHP coders that there is a prepared statement method for SQL queries. I know. A simple Stack Overflow search will find that for you. No spaces allowed. When spaces are not allowed or are filtered out, various techniques can be used to bypass this restriction. Comments to replace spaces, right? So you add a comment in the space. So select from users where name equals admin will become select, and then you're just commenting for the spaces. Tab or new line character is also very similar. This also works for command injection techniques, I've noticed as well. So we're using a tab or a new line just included in there for our spaces. And then alternative characters. We can use URL encoded characters such as that for horizontal tab, that for line feed, that for form feed, that for carriage return, and that for a non-breaking space. They can replace spaces in the payload. Got it. CTech said a lot of developers come from boot camp environments, no shade, and they often overlook security issues. It's true. It's true. And it's like the problem, whether you're a developer or something else, like the goal is like just get it to work, right? And what will often happen is in development, an application will be coded in a certain way or a feature will be coded in a certain way just to make it work in dev, all with the intended method of like, okay, I will update this before it gets pushed to prod, but then someone misses that, the ball gets dropped there, it gets pushed to prod, and you have the vulnerable code out there. I mean, I see this in real web app pen testing all the time with that kind of methodology. Let's just make it work in dev. We'll fix it before it goes to prod. They forget to fix it. It goes to prod. I exploit it, but better for me to exploit it than a real threat actor, right? But that's how some of these things will come into the real world. All right, in this scenario, we have an endpoint, search users.php username, that returns user details based on the provided username. The developer has implemented filters to block common SQL injection keywords such as or, and spaces to protect against SQL injection attacks. Here is a PHP filtering edit by the developer. So we'll see if I can also do it my own roundabout way. We have a special characters, no spaces, no ands, no ors, no union, and no select. If it's there, replace those characters with that. All right. Well, let me go ahead and follow along with this. Let me grab this link. Right, so we can at least right away, we see, okay, SQL injection might be possible. I did a single quote, and we got that SQL error. If we use our standard payload on the endpoint, which is just returning true, we can see that even though URL encoding is not working. Right, and it's not. What if we did... I have a weird way of doing this. So our issue is the spaces, right? But it says if you do one of their banned characters, it will add a space. What if you did banned characters to add spaces? Okay, no, that didn't work either. All right, I thought that would maybe work. So I thought it was maybe replacing the banned characters with a space. All right, let me jump over to this. The SQL query shows that the spaces are being omitted by code. To bypass these protections, we can use URL-encoded characters that represent different types of white space or line breaks, such as a horizontal tab or a line feed. These characters can replace spaces and still be interpreted correctly by the SQL parser. The original payload, 1 or 1 equals 1, for true, can be modified to use new line characters instead of spaces, resulting in this payload. But it's using new lines, so instead of spaces, it's using new lines that are URL encoded, rather. And there we go. We're able to dump our users. The SQL parser interprets the new line character as spaces, transforming the payload into that. Therefore, the query will be interpreted from select everything from users, where username equals username, right, to select everything from users, where username equals 1 or 1 equals 1. So in other words, where username equals true, and then we're dumping all the users. To summarize, it's important to understand that no single technique guarantees a bypass in dealing with filters or web application firewalls designed to prevent SQL injection attacks. However, here are some tips and tricks that can be used to circumvent these protections. This table highlights various techniques that can be employed to try and bypass filters and WAFs. All right, so scenario, keywords like select are banned. So this is what I did, guys. And that last one, I did that with or, right? I just changed the cases and that worked beautiful. Spaces are banned, right? Alternative characters for spaces and or and stuff are banned. Well, you can use different ways like or right there and right there to do the same thing. Common keywords like union and select are banned, right? Use hexadecimal or Unicode encoding, or honestly, the case stuff might work as well. And specific keywords like or and select union are banned. And then you can see a similar way we're doing concat. But you know, I would think if these are banned, concat would also probably be banned, but hey, it is what it is. In real environments, the queries you apply and the visibility of filter keywords are not directly possible. As a pen tester, it is important to understand that SQL injection testing often involves a hit and trial approach, requiring patience and perseverance. Each environment can have unique filters and protections, making it necessary to adapt and try different techniques to find a successful injection vector. What is the password for the username attacker? It is Tesla. Which of the following can be used if the select keyword is banned? That can be used. That can be used. We cannot, no, so that's not correct. So I'm going to go with C. All right, beautiful. Let me look at comments. Am I missing anything in comments? Just people having a good conversation about teaching. I love it. Also a great obfuscation method, you're right. And yeah, that is a great table right there. I love it, guys. Like, TryHackMe's been killing it, y'all, on the content releases. Like, they've been releasing rooms. What is it, like 2 or 3 walkthrough rooms a week and 1 challenge room every single week? And they've been high quality. Like, TryHackMe really is and has been stepping their game up. So kudos to the entire TryHackMe team. You guys are killing it. I really appreciate it. And just the fact that so much of the content's free. Like, this entire room is completely free. You don't need a sub at all to go through this room with me. Oh man, we got a lot of work to do. All right. Out of band SQL injection. Out of band SQL injection is an attack technique that pen testers use to exfiltrate data or execute malicious actions when direct or traditional methods are ineffective. Unlike in band, where the attacker relies on the same channel, out of band utilizes separate channels. There's HTTP, DNS, SMB. All right, so we have this cool little graph here. Here's us. We are the attacker on our attacker laptop running Kali Linux. We have our black hoodie on. We inject a malicious SQL command, right? The web server processes the injected command. The data server is like, and it gets broken by the command. It does an outbound request through the firewall, and it sends it back to our laptop, and we have the output of our command. One of the key advantages of out-of-band SQL injection is its stealth and reliability. By using different communication channels, attackers can minimize the risk of detection and maintain a persistent connection with the compromised system. For instance, an attacker might inject a SQL payload that triggers a database server to make a DNS request to a malicious domain controlled by the attacker. The response can then be used to extract sensitive data without alerting security mechanisms that monitor direct database interactions. This method allows attackers to exploit vulns even in complex network environments where direct connectivity between the attacker and the target is limited or scrutinized. Why use OOB or OOB? In scenarios where direct responses are sanitized or limited by security measures, OOB channels enable attackers to exfiltrate data without immediate feedback from the server. For instance, security mechanisms like stored procedures, output encoding, and application-level constraints can prevent direct responses, making traditional SQL injection attacks ineffective. Out-of-band techniques such as DNS and HTTP allow data to be sent over an external server controlled by the attacker, circumventing these restrictions. Additionally, IDS or WAFs and monitor and log SQL often monitor and log SQL query responses for sus activity, blocking direct responses from potentially malicious queries. By leveraging OOB channels, attackers can avoid detection by using less scrutinized network protocols like DNS or SMB to transfer data. This is particularly useful in network environments with limited direct connectivity between the attacker and the database server, such as when the server is behind a firewall or in a different network segment. Techniques in different databases. Out-of-band SQL injection attacks utilize the methodology of writing to another communication channel through a crafted query. This technique is effective for extracting data or performing malicious actions when direct interaction with the database is restricted. There are multiple commands within the database that may allow exfiltration, but below is a list of the most commonly used in various database systems. So in MySQL and MariaDB, we can do selecting the out file, which I've used to get web shells before, I think on CTFs, not the real world. This allows an attacker to write the results of a query to a file on the server's file system. And then you can do it via SMB or HTTP. Microsoft SQL Server, MS SQL, is XP command shell. Once again, another thing to keep in mind for those of you studying for the OSCP, because that might come up on your exam because it's taught in the course. But getting XP command shell and getting the shell from there, from SQL injection. Alternatively, open role set and bulk insert can be used. Oracle, you can use a UTL HTTP or UTL file packages to send HTTP requests. I see. Example, out-of-band SQL injection techniques in MySQL and MariaDB can utilize various network protocols to exfiltrate data. The primary method includes DNS, HTTP, and SMB shares. So with HTTP, we've already seen this a little bit. We're just doing a post request, right? Here's an example query to steal that sensitive data. DNS exfiltration bypasses HTTP-based monitoring systems. And MySQL does not natively support it. Oh, man. Attackers might use other means, such as custom user-defined functions. Got it. SMB exfiltration, that's interesting. In Windows environment, so you can actually use it to do SMB. That might bypass some of the filtering as well. This is fully supported as Windows natively supports SMB pass. Okay. Practical example. All right, let's get hands on. In this practical scenario, we will demonstrate how an attacker can exfiltrate data from a vulnerable web app using an out-of-bound SQL injection technique. The server-side code contains a SQL injection vulnerability that allows an attacker, that's us, to craft a payload that writes the results of a query to an external SMB share. This is useful when direct responses from the database are restricted or monitored. All right, in this scenario, we would enable a network share on the attack box where I'm on my own VM, so I'm gonna do my own VM, should work just fine. This share is accessible over the network, blah, 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 blah. So we're gonna use smb server.py to do this, and I've used that often to transfer files back and forth from Windows. Let's go ahead and give this a shot. Why the frick is that not on my path? Does that work? Okay, beautiful. All right, what are we doing with it? SMB2 support, we're just adding a comment, debug logs, and we'll do temp. All right, all of that honestly looks fine to me. All right, there we go. I got it set up. All right. We have the web application, the search feature that query visitors who visit the library. All right, let's pull that up. Thanks, Tim. Add a single comment, and we have the error. So what does the code look like? Well, we're doing a GET request on the visitor name, and our SQL statement is select from visitors where name equals visitor name. So there's literally nothing stopping the SQL injection. It's important to note that the MySQL system variable secure file priv may be set. When this is set, the variable contains the directory path name, and MySQL only allow files to be written to that specified directory, so you couldn't do the SMB stuff. When it is set, it will restrict file operations such as into-out file to the specified directory, can only write to this directory, limiting their ability to exfiltrate data. And when it's empty, MySQL does not impose any directory restrictions, allowing files to be written to any directory accessible by the MySQL server process. Attackers typically do not have direct access to check the value. As a result, they must rely on hit and trial methods to determine if and where they can write files. So preparing the payload. To exploit this vulnerability, attacker crafts a payload to inject in that. So pretty simple thing here. We're just closing out our query, and then we're trying to get the version information, and we're sending it to our out file on our SMB share. Okay. Let's give that a shot. So my attack box IP is going to be mine, 13.46.224. And we have it right there. Very cool. And then, of course, we have the comment at the end. To utilize the payload, the attacker would visit the URL that creates a file in an external SMB share. To access the file, use lstemp to see the file, which I did. What is the output of version? It is this. What is the value of the base directory variable? We just need to update this. Like that, right? And then change the file. We'll call it out1 since we already have an out.txt. There we go. Just took a second. So that's our folder we're in. Okay. Now I'm curious. I don't want to do that. What would SQL map do with this? Would SQL map, I'm sure we'll get to this, but. So obviously it discovers this injectable pretty quickly. Okay. Prompt for an OOB shell, interpreter, or VNC. I've never really used that. It would only depend, I think, XP command oh, it's MySQL, so it wouldn't be XP command shell. I don't know, guys, if this is going to work at all, but I thought let's just play around with it. Oh. It says it will fail, so it's not going to work anyways. I don't even know. All ports, connect back. Ten 13 46224. Yep, that is correct. Oh, is it trying to do it with Metasploit? Oh, shoot. My bad. No! I thought I had to open up my own. Let me, gosh dang it. Come on, Tyler. Don't be dumb, dude. Let me try that again real quick. I know that was a process, but I'm very curious if this will work. Even though it has nothing to do with the actual room. That's the fun of learning, right? You take it a step further, you dig in, you mess around, you play around, you see what happens. Come on, SQL map, go faster. What is the local address? Yes. Do 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 do. Will I get a call back? Nobody knows what is gonna happen. It probably won't work. I'm just capping. Alright. I'll let it do its thing in the background. Let's keep moving through the room. I don't think it's gonna work. Alright, other techniques. Advanced SQL injection involves a range of sophisticated methods that go beyond basic attacks. Here are a few important advanced techniques that pen testers should be aware of. Header injection. HTTP headers can carry user input, which might be used in SQL queries on the server side. If these inputs are not sanitized, it can lead to SQL injections. That'd be second order, right? Maybe. The technique involves manipulating HTTP headers like user agent refer x44 to inject SQL commands. This server might log these headers or use them in SQL queries. For example, a malicious user agent header would look like user agent that, if the server includes a user agent header in a SQL query without sanitizing it, it can result in SQL injection. How's this going? It's not going. Okay. In this example, a web application logs the user agent header from HTTP request into a table named logs in the database. The application provides an endpoint that displays all the logged entries from the logs table. When users visit a web page, their browser sends a user agent header, which identifies the browser and operating system. The header is typically used. Am I supposed to? Oh, let me go to this. Right, there's our thing. And if we turn on intercept and do the same thing, change. Can I even do some cross-site scripting in this as well? Ha ha ha! Look, not only can we get cross-site scripting, we have, or not only can we get SQL injection, I got stored cross-site scripting as well, right? Now, every time this freaking page refreshes, is it going to do that? Oh, no. Okay. Beautiful. I've actually done that on a real web app before where it was storing my user agent in logs, and I was able to get cross-site scripting on the admin user by just updating my user agent, just like I just showed you guys. So I've done that in the real world. Blah, blah. Given the endpoint, an attacker might attempt to inject SQL code into the user agent header to exploit SQL injection vulns. For instance, by sending the user agent header to a malicious value such as this, select username and password from user, an attacker attempts to inject SQL code that combines the result from the logs table with sensitive data from the user table. Here is the server-side code that inserts the logs. User agent, right into the server, insert SQL, insert into logs, user agent values, user agent. This is also why I get here echo new logs insert successfully, and then it echoes out our user agent. That's why I can also get cross-site scripting. Select everything from logs or user agent equals user agent. So if you escape this query, that's where you're going to have some issues. The user agent value is inserted into the logs table using insert SQL statement. If the insertion is successful, a success message is displayed. An error message details is shown if there's an error during insertion. All right, preparing the payload. We will prepare and inject a SQL payload into the user agent header to demonstrate how SQL injection will be exploited through HTTP headers. Our target payload will be union select username password from user. This payload is designed to close the existing string literal, right? That's that right there. Inject a union select statement. Is used to retrieve the username and password columns from the user table, so you would have to like know those, and then comment out the rest of the query. All right, YOLO, let's give this a shot. We'll just update our user agent like so. And sure enough, it works. We have Bob at Bob123 and our attacker and our Tesla password again. Oh, I guess you could have done a curl request, but I'm using Cato. With curl, you just set a header in your user agent. All right. I think I'm out of water, guys. I'm thirsty from all this talking. Did I ever get a shell? Nope. Okay, I figured that wouldn't work. All good. Let me close that out as well. All right, stored procedures are routines stored in the database that can perform various operations such as inserting, updating, or querying data. While stored procedures can help improve performance and ensure consistency, they can also be vulnerable to SQL injection if not properly handled. All right, SQL queries, stored procedure, read, insert, update, delete. It's SQL queries. Stored procedures are precompiled SQL statements that can be executed as a single unit. They are stored in the database and can be called by applications to perform specific tasks. Stored procedures can accept parameters which can make them flexible and powerful. However, if these parameters are not properly sanitized, they can introduce SQL injection vulnerabilities. Consider a stored procedure designed to retrieve user data on a username. Right here, declare, blah, blah, select from users where username, and then of course it's just pulling the username in from there. In this example, the stored procedure concatenates the username parameter into a dynamic SQL query. This approach is vulnerable to SQL injection because, once again, here's the key every time, the input is not sanitized. Oh, hey, Malware Combat, I apologize. I'm just seeing your question on YouTube. You said, I signed up for Pwn Labs but don't get how to connect. Are you supposed to connect to VPN from a Kali VM or my local, or is it all done through browser? Yeah, it's kind of like TryHackMe and Hack the Box. They have a VPN you download, and then you connect that way. All right, XML and JSON injection. Applications that parse XML or JSON data and use the parsed data in SQL queries can be vulnerable to injection if they do not properly sanitize the inputs. XML and JSON injection involves injecting malicious data into XML or JSON structures that are then used in SQL queries. This can occur if the application directly uses parsed values in SQL statements. All right? So here's our JSON. Username is admin or 1 = 1, and then password, so we can bypass some authentication. If the application uses these values directly in a SQL query, blah, blah, it could result in an injection. What is the value of the flag field in the books table where book ID = 1? We're still just using the thing that we're on here, right? Are we just doing the header injection? I think so. There was no other thing we were testing, right? This is all just the header injection. It's just giving us examples of these other ones. All right, what is the value of the flag field in the books table where book ID = 1? So in the books table, the flag field in the books table where book ID = 1. Can I do like union select? It's a flag field in the table. Can I do, I don't know. Oh, books ID. Let's try that. Hey, I did it. Union select book ID and flag from books. My error is I just had an S on my book right away, but I think that's the flag that they want us to get. THM hello. What was the hint? The columns are flag and book ID. Okay, I kind of figured that based on the description. What field is detected on the server side when extracting the user agent? What field is detected on the server side? What field is detected on the server side when extracting? I don't understand the question. What field is selected on the server side? Does it mean here? User agent? What field is detected, not selected? All right. What field is detected on the server side when extracting the user agent? Guys, for some reason, this question doesn't work in my brain. I'm just being honest. This question confuses me. I don't know why it confuses me. What field is detected on the server side when extracting the user agent. All right, chat, do you guys have any idea what this question is asking me? Frank said I also do not get it. Me neither, dude. What? I feel like it's a riddle. What field is detected on the server side when extracting the user agent? What the frick does that even mean? Headers? Is that the answer, Nefos? No, not headers. This is like Hangman. I should set up a Hangman thing, and every time we get it wrong, we get a thing on a Hangman and see if we end up losing. I already tried user agent. Oh, frick, it was user agent. I thought guys, didn't I try that? What did I do? I could have swore I copied user agent. Oh, I didn't underscore. I copied underscore agent. All right. That's I don't like that question. If anyone from TryHackMe watches this live stream, update that question. There's nothing necessarily wrong with it, but it's just like, it's very confusingly worded. Like I didn't understand what the heck it was asking me to do. But okay. Let us continue. Automation. SQL injection remains a common threat due to improper implementation of security measures and the complexity of different web frameworks. Automating identification and exploiting these vulns can be challenging, but several tools and techniques have been developed to help streamline the process. Major issues during identification. CTech, yeah, I agree, dude. Identifying SQL injection vulns involves several challenges similar to identifying any other server-side vulnerability. Here are the key issues. The dynamic nature of SQL queries. SQL queries can be dynamically constructed, making it difficult to detect injection points. Complex queries with multiple layers of logic can obscure potential vulnerabilities. A variety of injection points. SQL injection can occur in different parts of an application, including input fields, HTTP headers, and URL parameters. Identifying all potential injection points requires thorough testing and a comprehensive understanding of the application. Use of security measures. Applications may use prepared statements, parameterized queries, and ORM frameworks which can prevent SQL injection. Automated tools must be able to differentiate between safe and unsafe query constructions and context-specific detection. The context in which user inputs are used in SQL queries can vary widely. Tools must adapt to different contexts to accurately identify vulns. So a few important tools. SQL Map, this is the king. This is the one I use all the time when I'm working with SQL injection. I've never used SQL Ninja. Oh, it's specifically for Microsoft SQL Server as a backend database. Interesting, JSQL injection, a Java library focused on detecting SQL injection vulnerabilities in Java apps. And Barbecue SQL is a blind SQL injection framework designed to be simple and highly effective for automated exploitation. Interesting, I've never heard of that. Oh man, it has not been updated for 6 years. I don't even think it's maintained then. Honestly, just use SQL Map. Let's check out these other projects. Same. Has not been maintained for 6 years. Last commit was 6 years ago. How about SQL Ninja? 10 years ago. Frank said, maybe because it still works. I know it's a myth. Yeah, I don't know. Even if it works, generally you're adding new features and stuff. Like, especially for SQL injection, it just said up here, it's hard to detect it, right? There's all these different things going on. You have to constantly be updating it. But all these haven't been updated for years. Let's check SQL Map. All right. This is what I'm talking about. Last commit was 3 days ago. That's what I mean. Constantly being updated and fixed and added to make it better. Does the dynamic nature of SQL queries assist a pen tester in identifying SQL injection? Assist them? Does it assist them? No, it makes it more difficult. Best practices. We're almost done with the room. SQL injection is a renowned and persuasive vuln that has been a major concern in web application security for years. Pen testers must pay special attention to this vulnerability during their assessments, as it requires a thorough understanding of various techniques to identify and exploit SQL injection points. Similarly, secure coders must prioritize safeguarding their applications by implementing robust input validation and adhering to secure coding practices. Honestly, just look at Stack Overflow on your language, how you can stop them. But here are some good ideas. Number one, parameterize queries and prepared statements. Use parameterized queries and prepared statements to ensure all user input are treated as data rather than executable code. This technique helps prevent SQL injection by separating the query structure from the data. For example, in PHP with PDO, you can prepare a statement and bind parameters which ensure that user inputs are safely handled like so. There's that prepared statement that someone in Twitch talked about. Input validation and sanitization. Implement strong input validation and sanitization to ensure that inputs conform to expected formats. Validate data types, lengths, and ranges, and reject any input that does not meet these criteria. Use built-in functions such as HTML special characters and filter variable and PHP to sanitize. What was that? Oh, cool. It has a dictionary. To sanitize inputs effectively. Least privilege principle. Apply the principle of least privilege by granting application accounts the minimum necessary database permissions. Do not overly permission stuff. Avoid using database accounts with administrative privileges for everyday operations. This minimizes the potential impact of a successful SQL injection by limiting the attacker's access to critical database functions. Stored procedures. Encapsulate and validate SQL logic using stored procedures. This allows you to control and validate the inputs within the database itself, reducing the risk of SQL injection. Ensure that stored procedures accept only validated inputs and are designed to handle input sanitation internally. And finally, regular security audits and code reviews. Conduct regular security audits and code reviews, pen testing, all that good stuff. All right. Pen testers. That's me. Exploiting database-specific features. Different database management systems have unique features and syntax. A pen tester should understand the specifics of the target DBMS to exploit these features effectively. For instance, MS SQL supports the XP command shell command, which can be used to execute system commands. Leverage error messages. Exploit verbose error messages to gain insights into the database schema and structure. Error-based SQL injection involves provoking the application to generate error messages that reveal useful information. For example, using that can generate errors that leak version information. Bypassing WAF and filters. Test various obfuscation techniques to bypass WAFs and input filters. This includes using mixed case, which is what I did, concatenation, character stuff, hex, URL encoding, inline comments, all that fun stuff. Database fingerprinting. Determine the type and version of the database to tailor the attack. This can be done by sending specific queries that yield different results depending on the DBMS. For instance, select version works on PostgreSQL, while select add version works on MySQL and MS SQL. Pivoting with SQL injection. Use SQL injection to pivot and exploit other parts of the network. Once a database server is compromised, it can be used to gain access to other internal systems. This might involve extracting creds or exploiting trust relationships between systems. Advanced SQL injection testing requires a deep understanding of various techniques and the ability to adapt to different environments. Pen testers should employ various methods, from exploiting database-specific features to bypassing sophisticated filters to thoroughly assessing and exploiting SQL injection vulns. Methodically documenting each step ensures a comprehensive evaluation of the application security. What command does MS SQL support? XP. Conclusion. In this room, we have explored several advanced SQL injection techniques, including second-order, out-of-band, and filter evasion. We also cover techniques like cookie injection, illustrating the diverse methods attackers use to exploit web apps. Our journey did not stop at exploitation. We discussed the importance of automation in identifying and exploiting SQL injection vulns and leveraging tools to streamline and enhance our testing process. Understanding these advanced techniques is crucial for any pen tester aiming to uncover and address complex security flaws. Additionally, we discuss various mitigation measures to safeguard apps against these sophisticated attacks, emphasizing the need for a robust security posture. As a pen tester, your role is not only to find vulns, but also to understand the best practices for remediation and prevention. Armed with the knowledge from this room, we are better equipped to protect web apps, ensuring they are resilient against the evolving landscape of SQL injection threats. Let us know your thoughts on this room on our Discord channel or X account. See you around. Boom. Congratulations. We have completed this room. Share it with my friends. You guys are my only friends, so I'm telling you, I completed this room. You did it with me. How can I protect my WordPress? I have only 230 plugins. By deleting it. That's how you can protect it. Doc G Money said, I think the OSCP course writers could learn a lot about teaching this subject by simply doing this one room, in my opinion. I agree. But here's the thing. If this is OffSec, this would be like, hey, pay us $5,000 and we'll give you our SQL injection vulnerability. TryHackMe, the real MVPs are doing this stuff for free. I wanted to go back to this, though. I wanted to play around with this a little more. Let me add an hour. If I do something like, I have some ideas here. Was this the one where I can write files? Right? Yeah. Okay. Let me go back to, where the frick is the application URL at? I'm blind. That's the frick. Oh, here it is. I want to go back to this. Oh, let's turn off intercept. Let's turn it back on. All right, we got Tim. What up, Tim? What's up, homie? All right, now that we got Tim, we know that the base directory variable is examp MySQL. Where do you think the web app is? If I can put files in different places, would it be... I might need to know the name of the file. This is just on port 80, right? Site doesn't have a title. Okay. I'm going to copy this. We can even try this. Can I change that? No, I can't. What would be the default web route for this server on a Windows machine? Okay, I'm not quite sure about that Apache group thing. Here, I'm going to stop sharing my screen for just a moment while I log into the real ChatGPT. Okay. Okay, no, it's right. I just want to see, can I write to it? Right, so if how would I do that? It's totally outside the scope of this room. I mean, this works just for a quick POC. Oh, XAMPP is an all-in-one lamp stack. Oh, good call. Yeah. So if I write to this directory, okay, I don't know if this will work, but I'm thinking something like this. If I take this payload right here and go over to, did I send that to replay? Yes, I did. Well, here, I'll just do it in the browser. Screw it. and do something like I'll just do hello.txt. The web root. Okay. Maybe that won't work. I thought maybe I could do some interesting stuff with that, but... And honestly, probably someone smarter than me with SQL injection can. I freaking suck at SQL injection still. What if we do... What kind of things does SQL map give me? I want to see advanced help. All right, is there any like disable connections, disable logging? Path, one-click prompt. Yeah, I know I could write a PHP file that uses exec, but I don't know where the I don't know where the web root is. Like, I wanted to find the web root for sure by doing a simple one like hello.txt and then just verifying I can actually get to the web root. Does that make sense? So we could do this ourselves. We could do file right here. So I can do file right. Oh, that was the correct web root? Well, let's... we could try it. Although it is getting kind of late. Yeah, this is out of scope. I don't think I'm going to do it, guys. I would if it was earlier in the night, but we're getting close to midnight. And I feel like I'm falling down a rabbit hole. That's probably not even that useful. But I'll leave it up to you guys, right? That'll be a challenge for all of you. If you want to take this a step further, see if you can get a shell on here. And if you do get a shell, DM me on Discord. Just let me know how you did it. I'm curious. I'm sure it's possible. One of these SQL injection ways, it is probably possible. So y'all let me know if you're able to get it to work. But this is the end of this video. For those of you watching the standalone video on YouTube, thank you for watching. Hope you enjoyed going through this advanced SQL injection room with me. I'm still confused by SQL injection. Like, for some reason, it's hard for me to wrap my head around it. I understand how it works, but if you gave me like I had to manually exploit some complex SQL injection thing, I would fail miserably. So I can at least identify it, use SQL map, and then hope it works from there. Outside of that, I'm still pretty useless. But I still learned some new stuff on here. So thank you for joining me. I will see you in the next one.